All right, so we're going to finish up this section on other kinds of distributions. So although the normal distribution is the most important of all distributions in terms of analyzing data using our 68, 95, 99.7 rule, not all data can be approximated by this symmetric distribution with the mean, median, and mode all having the same value. Now, this histogram here, remember histograms are bar plots that are all touching, represents the frequency of the ages of females interviewed by Kinsey and his colleagues in their study female sexual behavior. This distribution, as you can see, is not symmetric, so we don't have a nice bell-shaped curve here. It's, kind of all of the big peak is here, then it tails off way down this direction. So the greatest frequency of females interviewed was in the 16 to 20-year-old range right here. Okay. Now the bar chart gets shorter and shorter after this, and the shorter bars fall on the right. So this indicates the relatively few older females were included in Kinsey's interview. So we had a lot in this region, kind of like in this area, but then it really falls off after that. Now, in our discussion of measures of central tendency, we mentioned that the median rather than the mean is used to summarize income. Now, this figure here illustrates the population distribution of weekly earnings in the US. All right, so that's kind of what we're seeing down here in this bottom corner. There's no upper limit on weekly earnings because as Americans, we can earn pretty much anything we want to as long as we have the means to work that hard or we have a well-paying job. Now, the relatively few people who do have those very high weekly earnings tend to put the mean income to a value greater than the median. So our median is right here, and our mean gets pulled up over here because of these high people. So we're getting pulled further and further this way. And so the more we have out this way, it pulls the mean that direction. Now our mode is going to be the one that has the highest frequency. So that's going to be kind of our peak here. So this is what we call a skewed distribution. Now, just a distribution of data that's skewed if a large number of data items are piled to one end or the other, and that's the tail is at the opposite end. So in the distribution of the weekly earnings here, this is skewed to the right. Okay, so we're skewing the data going to the right. So that's what we're doing. We're skewing the data way out here because these data are going to skew my median or my mean away from the median to the right of the where it should be. Okay. Now we can also skew data to the left. That's what we see in this next one. Now, here we're skewing to the low end, and so this is skewed to the left. Now, one kind of thing, if this is a zero, if there's a definite possibility of zero, then it kind of stops there. But we can think about how it could keep going down below and stuff like that. So these basically are what we're having is, again, here's our median. This is the one we trust, and anything that's too high or too low is going to skew it. Well, in this case, we're skewing this direction, and so our mean is below our median. And so skewed to the left means our mean's less than our median. And again, our mode is going to be that one with the highest value, and that's going to be the peak of our graph. All right, so that's all I have for this section. So hopefully that helps.